30 meter cube per minute for a mere consumption of 35 watts. So that's a whopping 6.57 service value. So we are going to submit samples to BEE, and they will have to come up with a new rating. Maybe it's a 5-star plus or a 7-star. What is the impact on the users? I have some calculations here how you will save money by using Superfans. If you use 10 hours a day and you pay 5 rupees per unit of electricity, if you run the fan at top speed, every year that standard fan will consume 273 units. You end up paying 1,369 rupees per fan every year. If you replace it with Superfan, it consumes just 120 units, and you save 767 rupees per year per fan. But if people use medium speed, again, a standard fan consumes 140 units, and you end up spending 712 rupees in a year. A Superfan will save you 420 rupees there. So in any which case, you see Superfan saves you a lot of money, and that's better than any bank's interest. Apart from this money benefits, we also have other super benefits with Superfan. There is no regulator, so you save the money of buying a regulator. The architect saves space on the switchboard. If you are using inverters, the Superfan runs for a longer time, or you can run 2 Superfans in place of 1. This BLDC motor does not generate any heat, so it runs cool. Superfan has a microcomputer inside, and any object comes in between the leaves, it can stop the fan. Of course, it's not going to prevent any injury, but it will, when it hits an object, it's going to trip. When you use the standard fans with inverter supply, you will find that it makes an extra noise. Superfans don't do. You won't even know that it's running off the inverter supply. When the fan is not in use, but still the power supply is coming to the fan, some little electricity is consumed. It may be small, but in Superfan, it indicates that the power is on. So you can switch off the wall switch and save even that little power. You'll also see that Superfan's leaves are designed very beautifully, and we have exciting colors for those leaves. So again, going back to how Superfan can impact India, if you replace all the existing fans with a Superfan, then India can save 28 crores every day. Chennai, the demand can come from 101 megawatts down to 44 megawatts, and it's going to save 26 lakh rupees every day. So how do we really make this Superfan? It has really got some super technology behind it. The body is of aluminum die-cast. The components used are from reputed brands. The leaves are made up of aluminum, so in Chennai you won't find any leaves rusting. There are 2 roller ball bearings from a good brand. It's not from any unknown make that would be cheap. All the components are industrially rated. This design has come about with computer-aided design software and it's simulated using finite element software by our experienced team of engineers. We have 2 patents pending on this technology, one for electronics and another for construction. When you look at the leaves, you will also see that there are no rivets projecting out of the leaves. The leaves are flat. You only see 3 tiny circles. And we had avoided the sensors also in this type of motor. We have 3 models currently. The first one is comfort. This does not run at that high speed what I was mentioning. This runs at a slower speed, still tries to deliver as much air as possible. So this will be useful where the fan needs to run quietly. This can be used in hospitals, classrooms of colleges and schools, workspaces, and even in air-conditioned rooms. Many of you might know already, but I will just repeat it for the sake of saving energy. If you are in an air-conditioned room, you should still use a ceiling fan to save energy. For example, if you set your temperature normally at 23 degrees, if you use a ceiling fan and run it, you can set the temperature to 25 degrees and still feel like 23 degrees. Each degree you set higher on an air conditioner, you will save 5% of electricity. So we have made this comfort fan where it will run quietly along with the air conditioner. Then we have other 2 models, Fast 48 and Fast 56. These fans can run at high speed, can deliver a lot of air. They can be used in different sizes of the rooms depending on the span of it, either 48 inches or 56 inches. Then we have very exciting colors. We have made this Superfan with a particular color pattern in our mind. All the colors we have indicated here will be only on the leaves. The fan's motor and other accessories will always be in white, indicating that it's a clean technology product. Here are some pictures of the models. This is a comfort model. You can see that the style is really inspired by nature. The leaves really look like more flower petals, but they can deliver a good amount of air. This is Fast 48. Then this is the Fast 56. Now, how reliable is Superfan? I will request Durga to come and share a few words on Superfan's reliability.
I'll now talk upon some aspects of the design which make this fan reliable. How reliable is the Superfan? A measure of a product's reliability is the mean time between its failures, which is usually measured in hours and also termed as MTBF. Superfan's estimated MTBF is 65,000 hours. That means by design, a Superfan can operate for 65,000 hours continuously without failure. Looking at it another way, you could operate a Superfan for close to 18 years without failure at an average of about 10 hours of running per day. Superfan is designed to work well over a wide input voltage range. It is designed to endure high voltages as well as low voltages on its input. Even a voltage as high as 300 volts AC on the input or a voltage as low as 120 volts AC on the input will not damage the fan. Let me now talk upon some aspects of the design which lend to the reliability of the fan. All the components used in the fan are carefully chosen and are of world class. All the electronic components are of industrial grade and are rated to withstand variations in the operating voltage and variations in the surrounding temperature. The circuits used are those similar to those used in TV and electronic ballasts. We have put an electromagnetic filter at the front in the electronics. This filter reduces external noise coming into the fan to a minimum. This helps the fan's microcomputer to run without disturbance, and thus the fan runs smoothly. We have built in various protections into the fan. The fan's microcomputer detects overvoltage, undervoltage, overcurrent, and continuously monitors the motors running. If any fault occurs or if the motor does not run properly, the microcomputer stops the fan operation and protects the electronics and the motor. Superfan is a super efficient fan. The losses in the motor are minimal. This means the motor runs cool, and as a result, the temperature surrounding the electronics rises only a little above the ambient temperature. This greatly enhances the reliability of the electronic components and in turn increases the reliability of the fan. Let me now talk some about the components used in the motor. We have used motor windings of the insulation grade of class F. That means the insulation is very rugged and it can withstand high temperature. One of the key components of a brushless DC motor is a permanent magnet. We use ceramic permanent magnets in the Superfan. These magnets can withstand high temperature and do not get demagnetized. This means the motor has a long life. Brushless DC motors many times use sensors inside. The sensors can be fragile and are prone to failure. In Superfan, we do not use any delicate sensors inside. This makes the motor very rugged. All the mechanical parts used in the motor are designed for close tolerances and they fit each other very well. This leads to reduced wear and tear. A major cause of failure in AC motors in fans is the exposure of the windings to voltage spikes. In Superfan, we avoid this problem completely. How we do this is, we supply the windings from a low voltage regulated supply. So the windings never get exposed to any voltage spikes. Superfan has been designed to meet IS 302, which is the Indian standard for safety of household electrical appliances, and also meets IS 374, which is the Indian standard for electrical fans. The fan has been tested at ETDC Chennai, which is a government body for product testing. It has been tested for immunity against voltage surges, fast transient voltages, and power supply interruptions. It has also been tested for continuous operation at high temperatures, temperature as high as 55 degrees centigrade, and a relative humidity of 95%. Thus, we have tested it in extreme conditions. To sum it up, we have made a very deliberate and intensive effort to build reliability into this fan. Thank you. Over to you.
Thank you, Durga. That should really inspire confidence into the minds about the new product. Let me just brief you on the market of ceiling fans. The world market is estimated to be $3 billion. To go to the world market, Versa Drives is very confident that it can do because we have experience in getting UL, CSA, and CE approvals for our existing products. So we can get these certifications for our Superfan also. The opportunities exist in the countries that lie on the equator, our neighbors, Sri Lanka, Malaysia, Philippines, Vietnam, then countries